Oi lads, it's Danny here today, bring you lot a lovely video. In today's video, we're going to take a look at how to solve the integral 1 divided by 1 minus x squared dx. Before we jump into it, I want you lot to leave a like and subscribe. So in order to solve this, what you lot are going to need to use is a partial fraction integration technique. There are multiple ways to solve this, but I'm going to use this method specifically. So in order to do that, what I'm going to need to do is I'm going to factor out a -1 from the denominator. And when you do so, you are going to have x squared minus 1. We are then going to do difference of squares basically. And once we have done that, we can rewrite the denominator as x minus 1 being multiplied by x plus 1. This is very important for our next step. So at this point on, what we're trying to do here is I want to separate this fraction into two. And the way we do that is with partial fractions. And this is the technique that needs to be applied. So we can rewrite 1 divided by x minus 1 being multiplied by x plus 1, close bracket. And it can be represented by two fractions with some fraction a in the numerator and some fraction with b in the numerator. So our goal here is to find what this a value is and this b value is, so we can have it represented in two different fractions. That's the idea over here. It just makes it a lot easier to solve. As it stands right over here, you can't really solve it. So the way we do this is we basically need to get a common denominator. So we're going to basically try solving it using a common denominator so they all have the same basis. So that as a result, you're going to have a multiplied by x plus 1 in your numerator, and on the b side, the b fraction I should say, you are going to have x minus 1 being multiplied with the b. And we are basically going to have an equation in terms of x, which is, you know, once you look at just the numerator, we'll just look at the numerator portion, right, which is just going to be the x variables. We don't have an x over here, so we're just going to have 0, right? And then here you have x multiplied with x in this fraction, and over here you're going to have bx. Now for the numbers, you are going to have 1 on the left hand side of this equation, and then you are going to have a minus b. So therefore we have two equations. So the idea here is we're trying to solve for a and b, and we're going to apply systems of equations in order to solve this. So we can rewrite this as 1 plus b is equal to a. I'm going to take this a term, we know that's going to be 1 plus b, and substitute it inside this equation. So when you do that, you are going to have is this, and we are going to basically simplify this. So this becomes, when you distribute the x's, basically you're going to have 0 is equal to x plus 2bx. As shown, you're going to bring the bx, 2bx on the other side, and the x's are going to cancel out really. So what you are going to be left with over here is -1 divided by 2 is equal to b. You're going to take this -1 divided by 2, and you're going to substitute it into here to get your a term. And when you do that, you're just going to have the positive version, which is 1 divided by 2a. So what we did here is we have taken this and broken it up into two fractions just to make it a lot easier to solve using partial fractions. That's the idea over here. So once we have it in this format, what we are going to do is separate the integrals, very important, and we are just solving very standard U-substitutions. If you look at the fractions, right, let's look at the first one. It's a very standard one. You are going to just take u to be equal to x minus 1, take the derivative on both sides. Afterwards, what you are going to need to do is you're going to take the integral of 1 divided by u du. When you take the integral of that, you are going to have ln absolute value of x minus 1, and we're just going to basically replace the u term, which we know is going to be x minus 1. On the second integral, it's the same idea. You are going to have u is equal to x plus 1 instead. You're going to take a derivative on both sides of this equation, right? And you're going to basically substitute in your u and du variable, right? And you're going to take the integral of 1 divided by u, which is going to be given as ln absolute value of x plus 1, which basically is our u term. Last step is to essentially replace these two the result of these two integrals inside this equation. So once you have done that, you've basically reached your final answer. Don't forget your plus c, and there you have it, lads. So if you enjoyed this video, please drop a like and subscribe, and I'll see you later.